Good morning. This is Professor Gardetto. I'm going to talk a little bit about homework number 11. This is week 4, your second assignment in week 4. I'm going to preview the assignment here and start the assignment. 19 questions, so similar in length to homework 9. So what we're doing in this assignment is we are multiplying rational expressions. Now, if we think about multiplying fractions, right, say we had 1/2 times 4/5, right? Well, when we multiply fractions together, we don't have to worry about finding common denominators. What we can do is we kind of do it two ways. We could, if we wanted to, we could just multiply the top numbers together, the numerators, and we could multiply the bottom numbers together, the denominators. And if we do it that way, we get, 1 times 4 is 4, and 2 times 5 is 10. And then we get a fraction. Most of the time, if we do the multiplication just from left to right, we get a fraction that we have to reduce. And so 4 over 10 reduces to 2 over 5. 2 goes into 4 twice, 2 goes into 10 5 times. So there's an extra step here if we multiply. To shorten this up a little bit, what we can do is do something called cross cancel. Right? We talked about canceling above and below yesterday, and we talked about some canceling rules yesterday. If you haven't seen the lecture from Monday, July 5th, you might want to go back and view that. Watch the mini video on homework 9. But if we do some canceling before we multiply, so before we multiply from left to right, if we do some canceling, so like there's nothing above and below that cancel. Nothing goes into 1 and 2. Nothing goes into 4 and 5. But if we look diagonal, okay, it's called cross canceling. So you look diagonal, and you basically do the same thing as if they were above and below each other. One's below, one's above, and 2 goes into itself 1 time, and 2 goes into 4 2 times, and then we multiply straight across, and we get 1 times 2 is 2, and we get 1 times 5 is 5. So we get that answer right away. We get the answer right away by cross canceling. Okay, so this entire assignment, I think 1 through 10 or 1 through 11, deals with multiplication. Okay, and then the last half deals with division. So we'll talk about division when we get there. But let's say we had a problem like this. Just like yesterday, before we start doing any type of canceling, we have to remember to factor. So anytime we see these plus signs, we're going to be factoring. So you take out a 2, and you end up with a z plus 4. That's just factoring out the greatest common factor, which is the first step always when you're factoring. So that's the numerator. The denominator is still 9z to the 4th. And the top there, you can't really factor that. That's just something I'll just write down. 8z to the 4th. And there's another plus sign there, so 4 goes into both. So it's 4 and z plus 4. So I had a student yesterday in the Zoom session ask if it was like a coincidence that every time you're doing these problems, you see something that cancels. And I told him no. It's these are built in such a way. All these problems are built in such a way that if you factor correctly, you're going to see a bunch of stuff that cancels. So I did my factoring here. So now this z plus 4 is gone. This 2 cancels with this 4, and that becomes a 2. What you might want to put is 1 when you when you cancel everything on top. you might want to put a 1. If you don't, you might forget to write it down. You might think there's nothing there, but there's actually a 1. I didn't put the 1 here because there was going to be a 1 over there. 1 times 1 is 1. 9 here, I'll show you what I mean. 9 goes into itself 1 time, and 9 goes into 81 9 times. I like putting these 1s here. Z to the 4th cancels with the Z to the 4th. So a lot of stuff that cancels. Make sure you're very neat and not too sloppy, so that you know what's left over when you do cancel something. So I'm like changing colors here. There's a 1 left over here. There's a 9 left over here. So 9 times 1 is 9. And there's a 1 left over here. There's a 2 left over here. So it's 9 over 2. They want you to write your answer as a simplified fraction. So 9 over 2 is simplified. So you pop that in right here in this square. Okay, so very similar to what we did yesterday with simplifying rational expressions. You're going to see two. You're going to see 2 rational expressions, and they're going to be multiplied. Okay, so let's go to a different one. I have these picked out ahead of time, so let's see, number 5. All right, number 5, multiply the rational expressions. Okay, so at first glance here, you might see only one rational expression, and you're correct. Y over y plus 4 is the only one you see. But this one here can be made into a rational expression. Remember, rational root word is ratio, so you can make this first term into a fraction if you just put a 1 underneath, and that way you know that that is the numerator. I'm going to go ahead and let's see. I have seen a minus sign there, so I think I can factor that. So that y is left outside, and I have a binomial that starts with y squared, so it's got to be y and y. And then the 2 numbers I put here have to multiply to get negative 16, but they have to add to get 0 because there's no middle term. So numbers that multiply to get 16 and add to negative 16 and add to get 0 are positive 4 and negative 4. Okay, so that's what's on the top. And what's on the bottom, or what's on the other side, I can't really factor y. And then I have a y plus 4 here. So this y plus 4, when I'm done with the factoring, I should do some canceling. So that y plus 4 cancels with this y plus 4. So now I have left a y plus 4, and a y. This y here doesn't cancel with this y here because it's got to be above and below. Okay, in order to cancel, one's got to be on top, one's got to be on the bottom. So this y multiplied by this y is y squared. Y plus 4, or y minus 4 left in parentheses. And then this is a 4 here. And then looks like there's just a 1 left on the bottom. You don't have to put a 1 on the bottom. If something's left on the bottom as a 1, you can just write that as your answer. Okay. Okay, so let's now, I think 11 moves to division. Let's see. So I think number 11 is division. All right, division. Let me give you guys a little bit of a problem here. See if you remember how to divide. 20 divided by 2. 20 divided by 1/2. Think about those 2 problems for a second. First one, I'm pretty sure you guys all got 10. If you didn't get 10, think about it a little bit harder. I think you all get 10. 20 divided by 2 is equal to 10. 20 divided by 1/2. You guys still getting 10? That can't happen. You can't take 20 and divide it by 2 and get 10, and then take 20 and divide it by a half and also get 10. So, what is this? Well, if we think about division for a second, division means breaking something into smaller parts. So, how many 2's are inside of 20? How many 2's are inside of 20? Well, there's 10. There's 10 2's inside of 20. There's 10 2's inside of 20. That's why 20 divided by 2 is 10. How many halves are inside of 20? If you had 20 donuts, 20 Krispy Kreme donuts. I'm making you guys hungry now. I know. If you had 20 Krispy Kreme donuts, how many half donuts are inside those 20? Yeah, 40. There's 40 half donuts inside of 20 donuts. Dividing fractions is not intuitive. Okay, it's difficult to think of because most people see this problem 20 divided by half and they want to put 10, right? Ask somebody on the street today what 20 divided by half is. Guaranteed they're going to say 10, right? But 20 divided by a half is not 10. 20 divided by half is 40. So the way we think about this so that we don't make that mistake is we change the problem to a multiplication problem. We do something kind of weird. We actually don't do a division problem at all. We take the first term, 20, and we don't change it at all. We just keep that first term. We take the division sign and we change it to a multiplication sign. Now, usually that's not allowed in math. You can't just change the problem. But we actually can. We can change the problem because watch, we're going to get 40. Okay? We're going to get 40. What we do with this fraction here, 1/2, is we flip it. We flip this 1/2. It's called the reciprocal. We flip it. We flip it upside down. We put the 2 on the top and the 1 on the bottom. And now look what happens. We have a multiplication problem. We take 20 and divide it by, or we take 20 over 1 and we multiply by 2 over 1 and we get our answer. We get 40. Okay, we get 40. Okay, so anytime we have division, we keep the first term, we keep the first fraction, we just write it down, we change the division to multiplication, and then we flip the fraction. And that's how we're going to do all these division problems from 11 through 19. All right, so I'm going to do that right here. 2p over 7. I'm going to keep. Division, I'm going to change to multiplication. And now I'm going to flip this fraction here. So I'm going to write the 63 on the top, and I'm going to write the 10p to the third on the bottom. Now it looks like a problem from 1 through 10. We do some, let's see, we can do some canceling. We don't have to do any factoring because I don't see any plus or minus signs. So let's see, I look diagonal. 2 goes into itself once. 2 goes into 10 5 times. P goes in, let's see, P cancels with one of these P's. So be careful if you cancel this exponent and just write the 2 there. Just make sure you don't write the 2 as big as you write the 5. Okay, because that 2 is not multiplied by 5. That 2 is going with the exponent. If you don't want to make that mistake, I would go like this, cross the whole thing off, and just write p squared. 7 goes into itself once. 7 goes into 63 9 times because I know 9 times 7 is 63. And then 1 times 9 is 9. And 1 times 5p squared is just 5p squared. Just got to make sure the p squared is on the bottom. Okay, and that's going to be what you pop into the box right there. Okay, the key thing is change it to a multiplication problem. Okay, let's try one more. Number 13. 13. Divide the rational expressions. Okay, so when you go ahead and rewrite it, and you're going to want to rewrite these problems, when you rewrite it, you might want to save a little time and factor it when you rewrite it. So like this term here, I'm not going to flip. I'm going to keep this term. I'm going to keep this rational expression the way it looks, but I'm going to factor out a q on the top when I rewrite it. There's a q common, and then I have q plus 8. On the bottom, I just have q plus 4. Okay. Now, I need to change this division to a multiplication. And now, how do I flip something that's not a fraction? Well, I have to make it a fraction. So you can put it over 1 to make it a fraction. And now you flip it. So if you flip it, the 1 goes on top, and the q plus 8 goes on the bottom. It's not a coincidence that we have a q plus 8 on the top, because those are going to cancel. So now we do our canceling. And, oh, here's a question. Does this q outside cancel with this q down low? They look the same. They look the same. That q looks like that q right there. But no, it doesn't cancel because this is attached, right? This is attached. Do you guys remember when you were like in high school and you put like A W plus MG and you wrote those in the tree? If you carved your initials in a tree, what's that mean? What's that mean if you see this written on a tree? That means two people are in love. That means two people are attached. They are attached. They are so attached they decided to carve their initials in a park bench or carve their initials in a tree. Okay? Think about this little plus sign as an attachment. Okay? This Q is not the same as that Q. That Q is attached to the 4. So the only way we could cancel a Q plus 4 is by another Q plus 4 up here. So this Q has to be on top, has to be left on top. So that Q times 1, that Q right there times this 1 is just Q. And then Q plus 4 is down below. A lot of people get a problem right, and then they cancel right here and they get the problem wrong. Okay? So don't cancel unless you have the same thing on top and bottom. That's what you're going to put up in here. You're going to put Q over Q plus 4. Okay? Good luck with the rest of homework number 10. We will have a live lecture later this morning. And then homework 11. I believe homework 11 is the last one. Let me see. I think I have 11 posted. Actually, this was homework 11 that I was talking about just then. Homework 12 for tomorrow. So I'll see you guys tomorrow.